Hello friends, welcome to the channel SafetyForum. Friends, today we are going to see how to calculate the safe working load for different ropes which you use in your company. So all of us know what is safe working load. So we will be seeing how to calculate this safe working load, what is the formula for different ropes, and also we will be seeing here the definition of safe working load, the rated capacity which is also known as manufactured rated capacity, and also the WLL, the very famous term, the working load limit. So we will be seeing the definition of all these terms here in today's video, and we will discuss what are they, and also in the end we will be seeing the different examples. Don't forget to send your email ID so that I can send you the calculation PDF which is available with me. So friends, before we see the calculation, we will be seeing the definition of these terms. What is safe working load? Sometimes it is stated as normal working load also, because it is the mass or force which a piece of lifting equipment, lifting device or accessory can safely use to lift, suspend or lower a mass without fear of breaking. So it is normal force or the mass which an equipment will be putting on to lift any load safely. That is known as the safe working load. So what is rated capacity, or which is also known as manufactured rated capacity, MRC? So it is the maximum gross load, friends. It is not the net load, it is the gross load which may be applied to the crane or hoist or any lifting attachment while in a particular working configuration and under a particular condition of use. So friends, as we discussed, safe working load is also known as normal working load. So in some aspect, if you see, this normal working load is not safe at all. Sometimes what we can say, it will vary, because safe working load is calculated by using a formula which is breaking strength divided by the safety factor. So this safety factor, it varies. Normally the range varies from 4 to 6, but in some cases, in case of heavy equipments, the dangerous equipments, we have to use the value of 10 or 12 in range. So the value of the safety factor will change, it will affect the safety workload. So in USA and in Australia and many other countries, they are using the term working load limit, WLL, which is replacing the safe working load, which is the maximum working load specified by the manufacturer. So it represents a mass or force that is much less than that required to make the lifting equipment fail or yield. So friends, first we will be calculating the safe working load for the FSWR, which is flexible steel wire rope. We will be seeing how to calculate the safe working load for the FSWR, which you can see in picture. So we are using a standard formula for FSWR, which is very much approved, and we will be seeing how to calculate this FSWR using a simple formula. So let us get into this. So friends, the formula is safe working load is equal to D square into 8, where D is the diameter of the wire rope which you are using, and it will be used in the unit mm. So suppose if you have the units available in inch from the manufacturer, then you have to convert it into the mm. So this is the formula which is commonly used for the FSWR, which is flexible steel wire rope. You have to use D square, the diameter of the cable, and the D square into 8. So we will be also trying to see it with an example. So for example, friends, if you take an example of 12 mm diameter cable, if is available with you, if you have 12 mm diameter FSWR is available with you, then you have to put it in the formula, which will be 12 into 12 into 8, where this 12 is the diameter mm of the cable. So you will get 1152 kilogram. So this unit will be in kilogram. So if you wanted to convert into ton, then obviously you have to divide it by 1000. So it will be 1.152 tons. So this is the safe working load for this FSWR, which is having 12 mm diameter. So this is the common formula which you can use to find out the SWL. And here this 8, many people used to ask which is the constant value which we can say used for calculation. This is a method to find out the safe working load. Now how you will calculate the diameter of the rope if you have the safe working load is available with you. So in some cases it happens like your company will ask you how much the diameter of the wire we have to use for a safe working load of 1152 kilogram. So in that case you have a formula D. The diameter of the rope will be calculated by root of L, which will be in kilogram, divided by the 8. The same formula, but when you try to find out the diameter, it will become root of the load. L is the load, divided by the 8. So we'll be seeing how to calculate using this formula. So now we will try to consider the previous example. We will consider our load, which was calculated. Let us take 1152 kilograms. So root of 1152, and we will divide it by the 8. So divided by the constant value 8. So you have to divide 1152 by 8. You will get 144, and we will find the root value of 144, which will be 12, and this will be in mm. So this will be the 12 mm, the diameter of the FSWR for using a safe working load of 1152 kilogram. So if the load is available in tons, you can convert this load into kilogram, and you can put it into this formula, and again you can calculate the diameter of the cable or the flexible steel wire rope. So this is how you use the formula to find out the safe working load or the diameter of the FSWR. So friends, now we'll be seeing how to calculate the safe working load for the manila rope, which is commonly used in the companies. So for manila rope, for the polyethylene, polypropylene ropes, the formula will be different. We'll be using the common formula, which will be like safe working load. You have to calculate using the breaking strength and the safe factor. So what is breaking strength? Breaking strength means, friends, the force which this equipment will stand until it breaks down. So the load or the maximum mass load which the lifting equipment can withstand until it breaks down. So up to that strength is known as breaking strength. So you have to use this formula for the manila rope, the polyethylene, the polypropylene ropes. The formula is safe working load equal to breaking strength divided by the safety factor. So we have discussed about the safety factor in the definition of the working load limit and all, right? So the safety factor, it will be like, generally it will be value from 4 to 6, and for higher equipments like lifting and all, we can consider it as 12, but in our formulas we will be using the general value, which will be 6. So as I said, from 4 to 6 we use, so we will be using the general value equal to 6. So how we will be calculating the breaking strength? Will be calculated by d square by 200. This 200 will be the constant value for the manila rope. For each rope it will change. For polypropylene it will be different, for polyethylene will be different. So this constant factor for each rope, you can even find it out by from the Google also. For manila rope it will be d square divided by 200. So you have to put your values here, and you can calculate the breaking strength, and once breaking strength is obtained, you can put it into the formula safe working load equal to breaking strength, which you find it out here, divided by the safety factor, which will be the 6 generally. So friends, let us see an example. We will take a common example here, and we will discuss the different case study. We will discuss about the 24 mm diameter manila rope. It is available. Just let us think you have 24 mm diameter manila rope is available with you, and you have to find the safe working load using this formula. We will repeat it with polyethylene, propylene ropes also. So first we have to find out the breaking strength. So for the breaking strength we have the formula, which will be d square divided by 200, right? So we will calculate this. So it will be 24 whole square, which will be 24 into 24 divided by 200. So we will be getting the 576 divided by 200, which will be the value 2.810. I have already done the calculation, so I will check it back and I will write the value for you. So it will be 310 you can approximately take, because after 0.5 you can make it you can round it out to 310, so it will be 310. So breaking strength is available. Now our aim is to find out the safe working load. So safe working load will be breaking strength divided by the safe factor. So we will put this breaking strength value, which will be 310, divided by the safety factor. Safety factor, as we have already discussed, the general value is 6, and for in critical situation we use for heavy equipments 12. So that is the reason this safe working load used to change, and now companies have started to use the working load limit, WLL. So this is the value 3 divided by 6, which will be 0.510. Now we will be seeing how to calculate the safe working load limit for the polypropylene rope. So suppose if we are using the polypropylene rope, how we will be calculating the safe working load using the same formula. So again we have to find out the breaking strength, and we have to put it into the safe working load formula. So breaking strength for the polypropylene rope will be D square divided by 77. So here the constant value will be 77. In Manila we have seen it was 200. Similarly here for the polypropylene it will be 77. So you have to put it into this formula, D square divided by 77. So friends, this PDF is available with me, the standard PDF. I can send it to you if you drop your email ID to me. So let us see the same example, 24 mm. We will be seeing the polypropylene rope, how to calculate it. It will be 24 whole square divided by 77. It will be 7.4810. So we will round it off to 710 because it is 0.48. So we will be rounded off to 710. So now what is safe working load? The safe working load will be the breaking strength divided by the safety factor. So the breaking strength is 7. So 7 divided by the safety factor we will be using, which is 6. So it will be 1.11810. So this is our safe working load for the polypropylene rope with 24 mm diameter if we are using in our site. Now we will be seeing the last one, polyethylene rope, how to find out the safe working load for the polyethylene rope. So for polyethylene again we will be using the same formula, breaking strength equal to D square by 106. Here the value will be, constant value will be 106. So we will be using the same case study, which is 24 mm polyethylene rope. If you are using in your company, how we will be calculating the safe working load. So it will be 24 whole square by 106, which will be 576 by 106. So it will be 5.4310. So approximately we will be seeing 510 weight. So now we will be seeing how to calculate the safe working load, which will be the breaking strength divided by the safety factor. So our breaking strength is 510. We will be putting it 5 divided by the safety factor. We will be implementing it, and you will be getting 0.8310. So this is the safe working load for the polyethylene rope. So I hope friends you have liked today's video. This is how easily you can calculate all the safe working load for all the different kinds of ropes. The constant values are also available in internet, and this PDF, if anyone of you want this PDF, please drop your email. I will send it to you so that it will be in your record with you. So don't forget to subscribe and share our channel also, friends. See you soon.